Now we would like to implement this simple delete method. So in the binary search tree, we just have to check whether the root is equal to null. So root is not equal to null. Then we just have to call the delete method on the root node and for example the data we would like to get rid of, and basically it's going to return the given root. So after the deletion it's going to return with the new root node. Okay, so let's create this method. It's going to return with a node, and it's going to have a node and the data as a parameter. Okay, sorry for that, I'm going to cut and paste it, for example, here. And Ctrl-Shift-F to auto format. So we just have to consider 3 cases, if you may recall. The first possibility is that the node we want to get rid of is a leaf node. The second case is when the node we want to get rid of has a single child. And the third case, of course, when the given node has 2 children. When it is a leaf node, first we have to search for it, starting with the root node. We find this given node and we just set it to null. What's very important that in Java, if we set this node 5 to be equal to null, it's not going to work. In C++, we can implement this remove method much more elegantly. But here, because Java doesn't support the reference-based method calls, that's why the recursive method call is not going to solve the problem. We have to notify the parent of this 5, which is the 4, that its right child has been updated, and we have to set it to null because we have removed it. Okay, it's going to be a matter of implementation, but because of this fact, the implementation is going to be a bit more complex. Okay, what about the second case? We would like to get rid of the 1. First, we have to look for it. Okay, we find the node we would like to get rid of, and we just have to make sure that the parent is going to point to the child. So the parent of 1 is 4, and we have to make sure that this 4 is going to point to the -2 directly. Okay, so we just have to update the references, and we have to set this node 1 to be equal to null in order to avoid obsolete references. Okay, then what if we would like to get rid of nodes with 2 children, for example the 32? Then we have to look for the in-order predecessor or the successor. We are going to consider the predecessor, which is the greatest item in the left subtree. So this is the predecessor. We have to swap the 2 of them, and basically here we are able to reduce the problem to an already considered one, because now we have to call the delete method recursively, and this time this node 32 is a leaf node, so we just have to set it to null. So let's try implementing it. First, because of the recursive method calls, if the node is a null, we just have to return with this node. Okay, or we could say that we are returning with a null, whatever. And we just have to search for it. So if the data that compared to the node.getData is smaller than 0, what does it mean? It means that this given data we would like to remove is smaller than the given node we are standing, so this one, so we have to consider the left subtree. So we just have to node that set left child, and we just have to call this delete method recursively on the node.get left subtree, so left child and the data. Okay, so what's happening here? Why do we have to use these kinds of method calls that we set the left child and the argument is basically a method call? Because if it's a null, for example, the node, the left child is a null, then we are going to return this node which is a null. And this is how we set the left child, for example, when the node get left child is a null. This is what I have been talking about a few minutes earlier, that we have to tell that it's not enough to set the given node to be equal to null. We have to notify the parent that, okay, this child is set to be null, so set the left child or the right child accordingly to be null. So this is how we set it, node.setLeftChild, and we call this method recursively. Okay, and else the data that compared to node.getData is greater than 0. What does it mean? It means that we have to consider the right subtree. So set right child, and we just have to call again this delete method on the node.getRightChild and the data. Okay, I think it's going to work just fine. What's the problem here? Okay, the if is missing here. So we just have to go to the right. In this section, basically, we are looking for the node we would like to get rid of. And else, what does it mean? That we have found the node we want to remove. Okay. By the way, in the end, we're just going to return with the node. And here, we just have to check whether this node.getLeftChild is equal to a null and the node.getRightChild is equal to a null. It means that basically it is a leaf node. What do we have to do? We are just going to print out that removing a leaf node, and we are just going to return null. That's what I have been talking about, that because we call this method recursively, sometimes if it's going to be a leaf node we would like to delete, just going to return a null and it's going to be printed here. So we set the right child to be a null, because we have to notify the parent that the given leaf has been deleted. So we're just going to return a null. Okay, if the node.getLeftChild is equal to a null, it means that basically it has a single right child, because here we have checked whether both of the children are null. If the program doesn't return, it means that either the left child or the right child is not equal to null. So if the left child is a null, it means that it's going to be removing the right child. Okay, and we just have to create a temporary node. So node, for example, temp node is equal to a node get right child. We just set the node to be null and return the temporary node. This is what we have been discussing, that if it has a single child, then basically we have to update the references and the parent must point to the child. And we set it to a null. So that's why, because these methods are going to be called, we set the left child or the right child to be the right child or the left child of that given node. This is the second case basically. Else if the node.getRightChild is a null, it means that it has a single left child. We do approximately the same. Okay, I'm just going to copy and paste it, sorry for that. Removing the single left child, and of course we just have to get the left child. And we set the node to be null and then returning the temporary node. Okay, so basically this is where we check whether the given node is a leaf node we want to get rid of. We're just returning null. We just set the leaf node to be null. Here we know for certain that the given node has a single left child or a right child. We have to decide. If the left child is null, we know for certain that it has a single right child. So we just have to remove it, update the references. As if the right child is null, then we know that it has a single left child, so we remove a single left child. And basically, if the program hasn't returned yet, it means that this is the node with two children case. So this is the most complex case as far as removing an item is concerned. We are going to do it in the next video. Thanks for watching.